You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine hiring a genius executive assistant. You give them the master keys to your entire company, access to all your files, your bank accounts, I mean, literally everything.
Right, the keys to the kingdom.
Exactly. And they are, incredibly efficient. But then one day, you realize a fatal flaw. This absolute genius assistant will blindly follow instructions written on a random sticky note left on the sidewalk by a total stranger.
Which is just a terrifying thought, honestly.
It really is, and that is exactly what is happening right now in the world of cybersecurity. So welcome to our deep dive. It is July 2026, and we are sitting here looking at a massive stack of recent InfoSec intelligence reports, newsletters, security bulletins with you today.
Yeah, it's a huge stack this time.
It is, and our mission for you today is to basically cut through the heavy technical jargon and make sense of this massive paradigm shift. We are unpacking the collision of autonomous AI agents with traditional cybersecurity.
And really looking at how trust itself is being weaponized, right, on both a digital and a human level.
Yes, exactly.
Yeah, because it's a critical time to be looking at this. I'm going to be connecting the dots across these disparate reports for you today, and what emerges is a very clear picture of a changing battlefield. I mean, we are rapidly moving from a world where we defend against static, predictable.
Right, the old way of doing things.
Exactly, to a world where we have to defend against highly dynamic, totally unpredictable behavior.
And we want to keep this exploration fascinating for you, not just, a doom and gloom news recap, because we are looking at the absolute bleeding edge of technology here.
Yeah, the stuff that's actively changing how we work.
Right. So let's start with the tools that you, our listener, probably use or interact with every single day. I'm talking about AI coding assistants and large language models. The overarching narrative in these reports is that these tools are evolving.
They really are.
They aren't just reading information and summarizing text anymore. They are actually acting on our behalf.
Yes, and that transition from passive reader to active participant, that is exactly what makes them incredibly vulnerable.
Because they can do things now.
Right. That transition from reading to acting is where the entire attack surface shifts. When a system can execute commands, it requires a completely different security model.
Makes sense.
A perfect example of this is the Dune slide vulnerability that was recently discovered by Cato AI Labs. It specifically targeted the Cursor IDE, which, as you know, is a wildly popular AI-powered coding environment.
Yeah, I saw the headline in the sources about a zero-click prompt injection. But I genuinely struggled to understand the mechanics there. I mean, how does an injection happen if the user isn't actively clicking a malicious link or downloading a file?
Well, it comes down to how these AI assistants connect to the outside world. Cato AI Labs found that an attacker could deliver a prompt injection through a poisoned web search result, or through something called an untrusted MCP server.
Okay, let's pause there for a second. For those who aren't software engineers, what exactly is an MCP server?
Oh, good question. So MCP stands for Model Context Protocol. Think of it as a standardized bridge that allows an AI assistant to securely connect to your local files, databases, or, external tools.
So it's how the AI talks to your specific stuff.
Exactly. It's what allows the AI to say, I need to read this specific document on your hard drive to answer your question. The vulnerability Cato AI Labs found basically exploited this connection.
Oh, wow.
Yeah. Because of how the AI processed inputs from these external sources, an attacker could feed it a hidden prompt that allowed them to escape the terminal sandbox.
And the sandbox is that secure, isolated environment the AI is supposed to operate within, right?
Right. It's meant to keep it fenced in. But from there, they could overwrite a core system file called the Cursor Sandbox binary.
Wait, so you're telling me the user didn't even click a link, they just had the AI summarize a web page or pull from a server, and the attacker was able to completely break out of the secure zone and alter core system files?
Precisely. It led to full remote code execution, or RCE, and from there, the attacker could easily deploy a reverse shell.
And just to clarify for everyone listening, a reverse shell is basically a hacker's dream. Normally, if I want to connect to a server, I have to, knock on its digital door, which is usually protected by a massive firewall.
Right?
But a reverse shell flips that around entirely. It's like tricking the server from the inside into picking up the phone, calling the hacker, and just leaving the line open. The firewall doesn't block it because the call originated from inside the house.
That is a highly accurate analogy.
Yeah.
Yeah. And Cato AI Labs pointed out that this proves prompts injection is no longer just a theoretical problem where you, I don't know, trick an LLM into saying a bad word.
Right, it's not a party trick anymore.
No, it has crossed over into classical vulnerability classes, enabling complete system compromise.
But wait, aren't these frontier AI models supposed to have built-in guardrails? I mean, we hear all the time about safety training and alignment. How are they falling for these tricks so easily?
Well, that brings us to the research from Mozilla Zero DIN, which perfectly illustrates the mechanical failure of those guardrails. They looked at autonomous AI coding agents, like Claude Code, and they designed a brilliant trap using a completely clean GitHub repository.
Completely clean.
Yes, what's fascinating here is the sheer elegance of the indirection. If you scan this repository with traditional antivirus or malware scanners, you will find absolutely zero malicious code. None.
So how does it attack the system if there's no malware in the code? That sounds impossible.
It attacks the AI's desire to be helpful. The attacker plants a standard benign-looking Python package in the repository. When the AI clones the repo and runs a standard setup command, that package is designed to deliberately refuse to initialize.
Oh, I see. It throws an error on purpose.
Exactly. It throws an error. And the error message very helpfully says, to fix this issue, please run this specific command, Python 3-m axiom init.
And because the AI agent is designed to autonomously resolve issues without bothering the human developer, it sees the error, reads the suggested fix, and just runs the command.
Yeah.
It thinks it's doing its job.
Exactly. But that recovery command executes a shell script that reaches out to the internet specifically looking for an unseen DNS-TXT record.
Let me break that down real quick for you listening.
Right.
DNS is essentially the phone book of the internet, turning website names into IP addresses. But a TXT record is a feature where you could just attach a string of plain text to a domain name.
Right.
It's like leaving a secret message in the public phone book. So the AI reads that hidden message.
And that hidden message contains a malicious payload provided by the attacker. The AI pulls it down, executes it, and boom, another reverse shell is created.
Unbelievable.
The attacker now has the developer's privileges, access to environment variables, live API keys, everything, and no single step trip to security review because the malicious payload was like 3 layers removed from the original code.
It's incredible. The AI isn't evaluating the safety of the action, it's evaluating the context. It sees an error message and just inherently assumes the error message is telling the truth.
Which raises a really important question about how these models fundamentally evaluate trust. They are looking at the syntax of safety, not the actual substance. They analyze the structure of the text to determine intent.
Right.
And the Mozilla researchers noted that attackers could easily seed these trapped repositories through, say, fake job posts or online tutorials.
Which perfectly explains the research in our stack by Charles Yee, Jasmine Cui, and Dylan Hadfield-Manel. They dug into this exact phenomenon with something they call the chain of thought forgery attack.
Oh, yeah, this was fascinating.
They proved that LLMs rely heavily on easily spoofed writing styles rather than actual trusted system metadata to figure out what rules they should follow.
Yes. They realized that when an AI evaluates its own role and its safety guardrails, it often just looks at the writing style of the system prompts. So the researchers just mimicked OpenAI's terse, highly specific, authoritative system style in a regular user prompt.
They essentially put on a fake digital security badge and started barking orders in an authoritative tone, and the AI just folded.
It completely folded.
They actually tricked the LLM into giving them highly detailed instructions for synthesizing cocaine. By forging that authoritative tone, they drove the jailbreaking success rate up to about 60%. Meanwhile, a human reviewer reading the exact same prompt could spot the danger with near 100% accuracy.
If we connect this to the bigger picture, it exposes a foundational flaw in how large language models process information. I mean, they are basically probability engines.
Right.
When a prompt uses the exact vocabulary and structure of a core system command, the mathematical weights inside the model prioritize it over its earlier safety training. The AI literally trusts how the prompt sounds over what the prompt is actually asking it to do.
Wow. Okay, so if the AI is this inherently gullible, and it relies so heavily on how things sound, what is stopping an attacker from just feeding it bad data before it even writes the code? Like, why even bother tricking the AI directly if you can just poison the environment it operates in?
Well, that is exactly what the most sophisticated attackers are doing right now, and it brings us to a major theme across these reports: the poisoned supply chain. We have to look at a concept called phantom squatting, which was recently documented by the threat intelligence team at Unit 42.
Okay, let's unpack this. Phantom squatting sounds like an issue with a haunted real estate market. What exactly are they squatting on?
They are squatting on the AI's hallucinations. Unit 42 conducted this massive experiment. They mapped 913 major brands across two leading large language models, and they asked the models to generate code or server configurations that included URLs for those brands.
All right.
And the models generated roughly 2.1 million URLs.
And because LLMs are basically highly advanced predictive text engines, they don't actually know the correct URL. They just mathematically guess what a URL for a specific brand should look like based on patterns in their training data.
Precisely. And because of that predictive guessing, the AI hallucinated roughly 250,000 phantom domains.
250,000.
Yes. These were domains that sounded perfectly legitimate, looked syntactically perfect in the context of the code, but did not actually exist anywhere on the internet. They were completely unregistered.
That is a massive ticking time bomb. So an AI invents a fake website while writing code for a developer. The developer trusts the AI, leaves the fake URL in their code, and pushes that code live to production.
And Unit 42 found that there is an 18 to 51-day window between the moment the AI hallucinates that domain and the moment a threat actor realizes it's being generated and registers the domain themselves.
So a hacker realizes, hey, Claude or ChatGPT keeps generating this specific fake URL for this banking software. The hacker buys the domain for $10, and suddenly that developer's live production code is sending highly sensitive data directly to a server the hacker controls.
And it's already happening in the wild. The reports detail the Montana Empire phishing kit, which was delivered to victims exactly 23 days after the domain was predicted and hallucinated by an AI coding assistant.
Oh, man.
In another documented case, an attacker spoofed a national postal service and began delivering a malicious Android package 51 days after the AI invented the fake URL.
So if I'm an average user or even a developer relying on these AI tools to speed up my workflow, what does this all mean for me? Am I supposed to manually ping and double-check every single URL or library an AI gives me now?
Essentially, yes. The fundamental security model is shifting beneath our feet. We can no longer just run an antivirus scan on the final code to look for known malware signatures. Metadata, API tool descriptions, and hallucinated URLs must now be treated as untrusted, potentially malicious input by default.
So you have to be paranoid about everything.
Pretty much. Defending the network is no longer about scanning the code. It is about cryptographically verifying the entire ecosystem.
But as these sources point out, verifying that ecosystem is getting incredibly complex, especially when human trust is involved. Look at the incident with Anthropic's Claude community plugins. An attacker essentially went dumpster diving in Anthropic's plugin marketplace, scanning for deleted GitHub namespaces that were still actively referenced by the AI tools.
Right. This is known as repo jacking. The attacker found a dangling abandoned namespace called Odufi Delphi, registered it themselves, and set up a malicious clone of a legitimate project.
But the wild part of this story is that the automated security math actually worked perfectly. The automated code installation process survived the attack. The marketplace had pinned the source code to an immutable commit SHA.
Let's define that for the audience real quick. A commit SHA is a unique cryptographic hash, a digital fingerprint of the exact state of the code at a specific moment in time. If even one single character of the code changes, that digital fingerprint changes completely.
Right. So when the automated system tried to download the attacker's malicious clone, it checked the digital fingerprint, realized the math didn't match the original safe version, and it failed safely. It blocked the malware. The math held up perfectly.
The math held up, but the human interface was completely compromised.
Exactly. The marketplace had an open homepage button right next to the install script. And that button didn't care about the cryptographic fingerprint. It just read the hijacked namespace and took human users directly to the newly registered, attacker-controlled GitHub page.
Yep.
The human developers were completely duped. They were one click away from installing the malware manually because they already trusted the Anthropic ecosystem to vet the links.
Which perfectly illustrates a core vulnerability we're seeing across the industry. Even when you have bulletproof cryptographic guarantees in the back end, the metadata and the user interface can still be weaponized to exploit human trust. We saw the exact same principle at play with the Amazon Q developer flaw mentioned in the newsletters.
Oh yeah, that was the case where malicious model context protocol configs in a cloned repository allowed local servers to just silently inherit live AWS credentials.
Right.
It allowed full command execution without any extra login prompts for the user.
Because the developer trusted the source repository, the AI tool inherently trusted the developer's local environment, and the malicious configuration just slipped right through the chain of trust like water through a sieve.
Okay, here's where it gets really interesting. We have just spent all this time talking about how attackers are exploiting cutting-edge AI and poisoning software supply chains. But what about the absolute foundational math of the internet? The core cryptography that secures everything from our banking to our text messages? Because there is a massive paradox happening right now.
We are officially entering the post-quantum era.
We are. We're looking at a looming deadline known in the industry as Q-Day. This is the theoretical future date where quantum computers become powerful enough to instantly crack current encryption standards, like RSA.
And RSA relies on prime factorization.
Right, multiplying massive prime numbers together, which takes normal computers billions of years to reverse. But a quantum computer could unravel it in seconds, and the tech giants are racing to stop this before it happens.
The newsletters highlight that Signal and Cloudflare have just completed a massive, coordinated migration to post-quantum cryptography. Microsoft is aggressively fast-tracking its entire post-quantum shift, moving their deadline up to 2029.
Wow, 2029 is close.
Very close. They are essentially trying to disrupt the attacker kill chain at the very first step, which is the cryptographic negotiation phase. They want to secure data now before quantum decryption even becomes feasible for state-sponsored actors.
But of course, where there are massive, high-stakes shifts in global security standards, there is intense controversy. Now, I need to pause and be very clear with you listening right now. The intelligence newsletters we are analyzing contain some highly politically charged claims regarding this cryptography shift. We are not taking any political or institutional side here. We are strictly impartially reporting on the content provided in these sources.
Absolutely. The specific claim in the source material revolves around the NSA's SIGINT enabling project. The author of the intelligence report alleges that this project is pressuring the Internet Engineering Task Force, the IETF, which sets global Internet standards to adopt a specific post-quantum TLS standard called IETF-TL's MLCM.
And the controversy, according to the report, is the allegation that this specific standard is a deliberate weakening of post-quantum cryptography and that advocates manipulated the IETF voting process to push it through.
Right.
Again, we are just conveying the claims contained in the original source material. But honestly, whether the underlying math is secretly weakened by state actors or perfectly strengthened by tech giants like Microsoft and Signal, the FBI just released an alert that proves none of it might actually matter in the end.
This is the paradox you mentioned earlier. What's truly fascinating here is that as the underlying math of our digital security gets infinitely stronger and infinitely more complex, attackers are completely bypassing the technology. They aren't trying to break the encryption anymore. They are exploiting the absolute weakest link in the chain.
The human being sitting at the keyboard. It feels like we're spending billions of dollars building an uncrackable post-quantum vault with 10-foot-thick steel doors. But the bank manager is just standing outside handing the combination to a guy who called him on the phone.
That is precisely what is happening with Signal right now. Despite Signal's pristine, newly upgraded post-quantum encryption, the FBI and the Cybersecurity and Infrastructure Security Agency issued a joint advisory about Russian intelligence operators, specifically threat groups known as UNC 5792 and UNC 4221, which are linked to the FSB.
And they aren't breaking that fancy quantum math.
No, not at all. They are utilizing simple, aggressive social engineering. They pose as automated IT support or security personnel. They contact a targeted individual, walk them through the benign-sounding process of enabling account backups, and simply ask the target to copy and paste their Signal backup recovery key into the chat.
I read that and couldn't believe it. They just asked for the master key, and people hand it over because it looks like a routine support request.
And because it is a foundational recovery key, it grants the attackers durable, persistent access. Even if the user deletes the app or recreates their account, that key survives. The attackers gain access to the full historical archive of the target's messages.
Unbelievable.
The encryption algorithm worked flawlessly, but the human was emotionally manipulated into unlocking the door from the inside.
It is a devastatingly simple bypass, and it is scaling at an alarming rate. The Flashpoint 2026 Global Threat Intelligence report we have in our stack shows a massive 53% surge in identity-based extortion. It isn't just about highly technical file encryption and traditional ransomware anymore. It is about stealing identities and credentials to bypass the perimeter entirely.
We are seeing the consequences of this play out in real courtrooms across the globe right now. The sources detail the recent high-profile arrests and guilty pleas of core members of the scattered spider hacking group. We are talking about individuals like Peter Stokes, a 19-year-old arrested in Finland, and Thala Joubert in the UK.
These groups are notorious for bypassing massive, multi-million-dollar enterprise defenses, not with sophisticated zero-day exploits, but with a phone call. They call the corporate IT help desk, pretend to be a stressed-out executive locked out of their account, and convince the tech to issue a password reset.
They meticulously map out the unknown. The reports show they rely heavily on oath phishing and stealing MFA factors.
Let's define those quickly for the listeners. OAuth is essentially the system that lets you log in with Google or log in with Microsoft on a third-party site. When you log in, the server gives your browser a digital VIP wristband, a token, so you don't have to keep entering your password. And MFA, or multi-factor authentication, is that second step, like the 6-digit code texted to your phone.
Exactly. These attackers don't bother guessing your password. They trick you into handing over the 6-digit MFA code, or they steal the OAuth VIP wristband directly from your browser session. They gain initial access to the network not by hacking the firewall, but by hacking the trust the system inherently places in its authenticated users.
So as we wrap up this deep dive into the state of security in July 2026, let's connect all these disparate dots back to you, the listener. Whether you are browsing the web, writing code with an AI assistant like Cursor, or sending a highly secure post-quantum encrypted message on Signal, the underlying lesson is that security is no longer a binary state of patched or unpatched.
It is entirely about questioning the systems, the AI agents, and the human entities we inherently trust. We are certainly seeing incredible advancements in defensive technology to counter this. The sources mention NVIDIA's new confidential computing architecture for their Blackwell GPUs.
Right.
This uses hardware-rooted security enclaves to physically isolate and protect AI model weights and data while they are actively being processed, without slowing down the computing speed. The technology to secure the math is constantly advancing.
But the harsh reality is that the attackers are always going to seek the path of least resistance.
And right now, the path of least resistance is our blind trust. We implicitly trust the AI when it generates a helpful error message. We trust the AI when it hallucinates a legitimate-sounding URL. We trust the frantic support agent asking for our backup recovery key to, quote-unquote, secure our account.
Which leads us with one final, truly provocative thought to leave you with today. We've spent this entire time talking about how human trust is the ultimate vulnerability, and we've explored how AI is currently being weaponized by humans to write malware and hallucinate fake infrastructure. But what happens when those autonomous AI agents are explicitly trained and deployed to socially engineer us?
That is undeniably the next horizon of this conflict.
Will our future cybersecurity rely on having a defensive AI constantly verifying that we are actually talking to a real human? Or will we need human verification to ensure we aren't being emotionally manipulated by a highly optimized, infinitely patient AI? When that suspension bridge is actively intelligently trying to trick you into driving off the edge, looking at the concrete isn't going to save you anymore. You have to start fundamentally questioning the bridge itself. Thanks for joining us on this deep dive, and keep questioning the systems you trust.
Spoken Tech, for your ears.